next up, we have Andrew Betts. He is a developer working in developer relations at Fastly. And Andrew is joining us from the UK today. Where in the UK are you, Andrew?
I'm in London.
In London, okay. So Andrew is a developer relations engineer, and he likes helping people do creative things with the Fastly network. He also likes making cocktails and biscuits in the UK sense. So I guess for me that would be cookies, and automating all of the things in his house. So Andrew, whenever you're ready, you can take it away.
It says I can't start sharing until you stop sharing.
Oh yeah, I have to bump myself off. Go for it.
Okay, is everybody seeing my slides? Yep, great. All right, well, my name is Andrew Betts. I work for Fastly, and I want to spend 20 minutes sharing my enthusiasm for HTTP headers with you. I call them serverless programming for the network. I think they are much underappreciated as a way to control your website and give you better security, better performance, and lots of other useful things. Ooh, I am not focused on the right window. Okay, so 1997, HTTP 1.1 has just been standardized, and an HTTP exchange looks like this, which is lovely. You can read it, and it makes sense. And today that looks like this, which you can't read and doesn't make sense. So the question is, did we go wrong somewhere, or does all of this do something useful and valuable for the web? And do you know what all of these mean? Did you copy and paste them from Stack Overflow and you don't really know why? Or like, are you a maven and you understand everything about HTTP headers? So I hope to dive into some of these today. This talk was inspired by a guy called Steve Souders, who I come across occasionally at conferences. He's written all the books on web performance. And he asked me an interesting question once. He said, Andrew, in 2012, I wrote this blog post about self-updating scripts because I run a service that provides performance analysis of people's websites. And so I have to run my script on their websites. And it would be kind of ironic if my performance measurement service was the reason why other people's websites were slow. So my thing has to be really fast. So I cache it in the browser, but I also want to be able to release updates to my service whenever I want. So I want a mechanism whereby I can make browsers clear their cache. So he wrote this blog post about self-updating script, and it was a really terrible hacky solution, but it worked. And he said to me, like sometime around 2017, there must be a better way of doing this now. So how, as a developer, can I clear the cache in the browser? So I said, well, Steve, surely you must have heard of the clear site data HTTP response header. Now, at the time, I was on the W3C's technical architecture group, and so we kind of see all of the standards that are being proposed by browser vendors and other people, and review them and make sure they're sort of in line with how web architecture works. And so I just sort of imagined that everybody was using these things now. And this particular header works like this. You just attach it to any response that you send from your server, and it will clear everything associated with your origin from the browser's cache. Obviously, the request isn't going to be for the thing that you want to clear from the cache because the browser's got that in the cache, so it will just respond from the cache. So you have to convince your user's device to make a request for something else, anything, and then you can attach this header to the response. And Steve said, wow, that's amazing, Andrew, you should write a blog post. So I did. And in writing this blog post, I discovered that no browser supports this feature, which was seriously disappointing. But it does mean that I get years of mileage out of this talk because 3 out of the 4 major browsers that I looked at in 2017 do now support this feature. Still waiting for Safari, unfortunately. But this gives you an idea of just how long it takes some of these features to gestate once they've been standardized. So I thought, okay, let's look at some other headers. And then I got carried away and looked at basically all of them. This is a SQL query from HTTP Archive showing you some data about how popular certain headers are on the requests and responses that HTTP Archive records. For those unaware, HTTP Archive is a project, an open source project sponsored by Google and Fastly and many other people that crawls the web every 2 weeks and puts a vast amount of data into a BigQuery database that anyone can query. So This is the entire stalk in one slide on the basis of the research that I did and everything I'm about to tell you. Headers you should use, headers you shouldn't use, and headers that won't work today but will help you in the future. So let's dig into some of these. First of all, those that we don't want, and this is the fun section. The most surprising finding of my research was a header called P3P. And let's have a little bit of a practice audience participation. If you've heard of P3P, push one of the reaction buttons. Okay, so either the reaction feature doesn't work or no one's heard of P3P. Interestingly, I found that almost every response in HTTP archive that was setting P3P, and it was about 10% of them, was setting it to this. And this is curious because it's like saying, you know, I am not what I clearly am. So why were they doing this, and what is this P3P nonsense? So it turns out it stands for Platform for Privacy Preferences Project, which is a real mouthful to try and say in a conference talk. And it was intended as a declaration of machine-readable privacy policy. It was only ever implemented by Microsoft in Internet Explorer, and they implemented it really badly, although it wasn't really their fault. The problem was that there wasn't a lot of need at the time for a browser, a native browser UI that explained privacy preferences to the end user. So no research went into it, and the UI never really got created. But the browser did require a P3P policy to exist in order to give the website access to certain features that the browser exposed. So developers would just set the value to anything and it would pass the test. So that's why you see P3P policies that say this is not a P3P policy. That's a really terrible result, but it is a good example of how the standards process can kind of go wrong in unexpected ways. Also, these things are the bane of our existence today and are all over the web. And actually, if P3P had been invented 15 years later, possibly we would now have a much better way of dealing with cookies and all of that kind of stuff. But don't use P3P, it's useless. Now, to go from something that no one's heard of to something that everyone's heard of. So press your reaction button if you've heard of expires. Okay, so the reaction buttons definitely don't work then. Or am I just not seeing this? Expires, everyone should have heard of this. This is a header that simply tells the browser when your response should be cleared from the cache. Why on earth would I not like expires? Well, the main problem with it is that it's always set to Thursday, the 1st of December, 1994 at 4 p.m. I say always, it's about 40% of the responses in HTTP archive are set to that date. But that is super curious, right? That's billions upon billions of responses that all have the same date across many thousands of different domains. So why has everybody agreed that their content expired, over 25 years ago? So the answer is, it's the example in the specification. Now, why do people copy the example from the spec? Well, I think two reasons. First one's practical reason, and the second one's more of a sort of psychological reason. The practical reason is that the HTTP date format inexplicably includes the day of the week. So if you can see my mouse cursor, I'm just pointing out the Thursday. You have to know that the 1st of December 94 was a Thursday. Now, I don't know that, so I'd have to go look it up, but it's much easier for me to copy an example. The second reason is that psychologically, if you want a date that's in the past, for some reason you want a date that's a long time ago, which is completely unnecessary. 5 minutes ago is just as expired as 25 years ago, but people feel better about using dates that are a long time ago. Now, right next to this piece of the specification, there is this text that says, if a response includes a cache control field with max age, a recipient, i.e. a browser, must ignore the expires field. Can't miss it, it's right there. So you would think that there would be no responses in HTTP archive that include both a cache control max age header and an expires header. Actually, there are loads. So 78% of domains in the archive are setting expires, and 64% of those are also setting a cache control with a max age, which means their expires header is ignored. The other interesting thing about caching headers is that if you don't want your response to be cached by anything, whether it be a CDN or the browser, some people go to extraordinary efforts to construct this sort of fruit salad of headers that will try and communicate just how strongly they don't want their content to be cached. And this is a good example of that. So, we have a bunch of headers here that all override each other. This is the only one that's actually useful, so we don't need this one. Pragma is often seen as a response header, but it's actually only a request header, so that has no meaning in the response context. Post-check and pre-check are proprietary extensions to cache control that never got standardized, so those are useless. No store is useful, but including no store will imply no cache, so we don't need that. No store also implies must revalidate, so we don't need that. And no cache implies max age 0, so we don't need that. Private is also useful. That prevents caches like Fastly that are shared caches from delivering this one response to multiple parties, which we can still do without storing it on disk. So no store does not prevent us from doing so-called request collapsing, where we combine multiple requests into one. But making it private will also prevent us performing any transformations on the content, so that implies that. So here we are. This is all you need. If you don't want something to be cached, cache control, private, no store, and you're done. X-frame options is another header that I don't like very much. And this one is requires some explanation because the purpose of X-frame options is quite laudable, which is that we are trying to prevent our website being framed by another website. In principle, this is like quite a nice thing to allow people to do, but in practice, you tend to want to prevent it because it will allow for things like clickjacking when a malicious website will load your website in an iframe, hide it, and then convince someone to click in it. So it's a good thing to do, but it's just not the best way to do it because there is a directive that's part of the content security policy header framework, which will also do the same thing, but in a more interoperable and better specified way. So rather than using X-frame options, same origin, consider using content security policy frame ancestors itself. The other good reason to do this is because you already have a content security policy, don't you? Anyway, moving swiftly on. The final header I don't like and which I want to mention before I go on to the good stuff is the via header. And the via header is an interesting one to bring up in this context because it is not a request header set by a browser and it's not a response header set by you. It is an intermediary request and response header set by CDNs and proxies, like Fastly. So when a request passes through Fastly, we will add a via header to it. And when you send a response back, we will add a via header to that as well. Why? Well, for not any particularly good reason, honestly. The best reason for adding a via header is to prevent this, what we call forwarding loops. So let's say you have a Fastly account and you also have a service configuration with another CDN. So you set up your Fastly service configuration to point at the other CDN, and you set up the other CDN to point at Fastly. And the internet explodes because we just keep passing this request backwards and forwards. So this is a bad thing, and the via header is intended to be part of the solution to that problem. But it's not a great solution. For a start, it includes a response element, which doesn't really help us with this forwarding loop, because if we've got a response, then we obviously made it to the server, like we're not in an infinite loop. It also is a bit weird. It comprises two elements. The first one is the version of the HTTP protocol, 1.1, and the name of the caching software, which in Fastly's case is Varnish. Now, Varnish is an open source piece of caching software, and we're not the only CDN that uses it. So that isn't really very, it doesn't really identify us uniquely. So here's a summary of all of that. Via is, in principle, a solution to a real problem, but it also tries to solve a bunch of other problems that don't really exist or which it doesn't solve very well. So let's talk about the headers we do want, and let's start by solving the via problem. So Fastly has been collaborating with some other CDNs like Akamai and Cloudflare, and this is quite an interesting initiative because we don't really do this very much. So, Apple and Google and Mozilla and Samsung have been getting into rooms together and talking about web standards for 30 years. But CDNs really don't do this. So we're quite pleased that we've been able to kick off this kind of cross-industry collaboration with something quite simple. And what we've created is something called CDN loop. So let's imagine a request arrives at Fastly. This is using one of Fastly's debug tools. And the request contains a CDN loop header with a value of Cloudflare. So that means that the request has already passed through Cloudflare before it got to us. So we will simply add our Fastly token onto the end of it and send it on its merry way to the origin or to the next layer of caching. We will also prevent you from modifying it. So that's part of the CDN loop standard, that we will make, every CDN provider will make sure that the CDN loop header is protected from modification. Similarly, we're also working on a standard called cache status, which I would recommend that you go check out. It's quite cool. You might be familiar with CDNs and other caching proxies setting response headers called Xcache or something like that, that will tell you whether the object that you loaded from your domain came from the cache or whether it had to be fetched from your origin server. Now, every CDN does that slightly differently. There is a sort of casual consistency around the use of the header name Xcache, and but what it says, whether it says hit or miss or forwarded to origin or something like that, there's no real consistency. So we are working to create a standard for this. It's called cache status, and it will name the cache through which the response is passed, and it will give you some standardized property names that you can start to report on and using your performance metrics to understand the performance characteristics of your website and how the cache got involved in that. Now, I mentioned the content security policy earlier, which everyone obviously has. I say that with a bit of a laugh because, very many people don't. And there's a good reason for that, which is that it's just very complicated. In principle, the content security policy is quite simple to understand. You are creating a firewall in the browser. So someone loads your web page. That's the first arrow at the top here. And then once that web page has been loaded, it will then start loading loads of other things like scripts and style sheets and images and Discuss and like loads of third-party stuff and your Google ads and everything. Now that will involve it reaching out back to your server, but also to a bunch of other third-party servers. And the content security policy literally just is a list of the third parties that you expect to use on your site. And if the page were to try to make requests to anyone else, then it would fail. And this is useful for avoiding situations like this. This is one of my favorite posts on Medium by a guy who wrote this incredible story about how he's harvesting credit card numbers and passwords from your website. I would recommend you reading it. You'll be very scared by the time you get to the end, and then you'll realize that it's all a joke and it's fine. But maybe it's not, and maybe someone else really is doing this on your website and you don't know about it. So we should all deploy as many defenses as we can to try to protect our businesses and also our users. So content security policy is one simple example. And this is a simple example of content security policy from MDN, and as a developer network. The problem is, whilst MDN is very good at creating examples that make this technology very accessible and very understandable, this is a theoretical example, this is a practical one. So when I went looking in HTTP archive, this was the longest content security policy header that I found. I think it's safe to say that no one actually wrote this. I think this has probably been generated by a tool. But it's also safe to say that it is completely useless. So not only is it almost 10 kilobytes of data that will precede any page that you serve to your users, which is already pretty bad, but it also stipulates unsafe inline, unsafe eval, it whitelists star.cloudfront.net, tagmanager.google.com, both of which are domains that anyone can upload anything to, basically, and my personal favorite, star.amazonaws.com. This is 10 kilobytes that may as well just be a comment preceding whatever you're serving to your users. So have a content security policy. It's really important, but have one that works and write it yourself. Don't generate it automatically. Now, from content security policy that's quite difficult and hard, maybe sometimes hard to get right, to something that's a quick win and incredibly easy to get right, strict transport security. With this header, you can ensure that browsers will always connect to your website over TLS, even if somebody types the address explicitly with HTTP or leaves off the protocol entirely, which is everyone. You can do this simply by setting strict transport security with a max age in the response. That's generally a constant. Just apply it to all of your responses and you're done. Interestingly, this is an example of a type of header that I don't like very much, which is to say it applies to every action on your whole domain, even though it's essentially supposed to be response metadata for a single response. So those of us who get pedantic about what the web means and like what the headers are supposed to be for, get slightly het up about the idea of using response metadata on a single response to affect the behavior of the entire domain. But this is a very useful behavior to have, so I would recommend that you do it. Referrer policy in the same kind of category. Referrers have been around since the dawn of the web, and they've been being misspelled for that entire time. Referrer policy is spelled correctly, so make sure that you put 2 R's in there, and that will help you to tell the browser what to do when it sets the referrer header. So when somebody clicks a link from your website to somebody else's website will get a header telling them where that user came from on your site. But that could be leaking lots of private data in the query string of the URL that they came from. If your site uses query strings at all, and even if it doesn't, frankly, because you might introduce them in the future, make sure you have a referrer policy that excludes query strings from referrer headers on outbound links. Origin when cross-origin is a good default setting. It is unlikely to break anything. For this and many more security tips on HTTP headers, try securityheaders.io. It will give you your site a grade, and it will also give you a bunch of advice. Nothing to do with Fastly, but we like to recommend it. So on to performance. Link rel preload is a sort of Swiss Army knife of performance improvement capability for your site. In fact, the link header is another one of these incredibly old headers that's been around since the early days of the web. But it used to be intended for previous, next, and table of contents links. But we don't do that anymore because that's not really the way the web works these days. So instead, we now use it for referring to resources that are needed by the current page. And the most important example of this is fonts. Sorry, over a second. Fonts are a problem because when you load an HTML page, immediately you'll see text, and that text will not be in the correct font. Then it will find a style sheet, and it will load the style sheet, and then it will find a font face declaration, and then it will load the font file, and now your text is in the right font. So there's this massive differential between when you need the font and when you actually get it. So that's where link rel preload can really help to bridge that gap. This is an example from Tinder, 2017, when they applied link rel preload, massively sped up the loading of their JavaScript and their fonts. This is an obvious thing, everyone should do it. There is a limitation to how much it can help you, and that limitation is that we have to send the status code before we can send any headers. So we can't send that link rel preload until we know whether it's a 200 or 404 or 503 or whatever. Sandra, yes, I did say Tinder, the dating site. So the status code, what is the status code problem? Well, I type in your web address, www.yourwebsite.com, and I press enter. What happens? The web browser will then do a DNS lookup, and then it will negotiate a TLS connection. Can't do anything about either of those, and we can't do anything else at the same time. But now your server has received my request, it's going to start thinking. And it's going to think in terms of things like database queries, authentication, templating, API queries, a bunch of other things, all sorts of stuff that your Rails or Django or whatever application server is going to do. What is the browser doing while that's happening? Nothing. It's just sitting there idling. And that period of time is critical because as soon as you start sending a response down to the browser, all sorts of stuff is going to start happening. It's going to start loading your style sheets and your JavaScripts and your images and everything. So this period of time is actually really useful and we're not using it. So what if we could send some link preload headers even before we've decided whether this is a 200 or a 404? So welcome to Early Hints. Early Hints is a new spec that Fastly is working on, along with a bunch of other people. It is not a header, it is a response code. So in theory, if we get enough web servers, CDN vendors, and browsers to adopt this, you will be able to send a 103 early hints response, which says, I'm not really sure what this is yet, but have some headers. And those headers could be anything, but are likely to be link rel preload headers that will tell the browser to just start downloading the fonts and I'll get back to you as to whether this request makes any sense. And then later you could even send a 400 to say like, this request doesn't make any sense, and you loaded some fonts. But in the majority of cases, you're going to say, okay, yeah, this request makes sense. Here's your page, and by the way, you need those fonts that I told you to start downloading. If we manage to do this, then we can send those early hints within a couple of milliseconds of receiving the request. You can start downloading the fonts, and then a few tens or hundreds of milliseconds later, you can follow up with whatever the final verdict was on that request. Okay, I'm running out of time. So in summary, headers on the left, good idea. Use those, look into them, look them up on MDN. They're going to help you. Don't use the ones in the middle. You probably aren't anyway, apart from maybe expires, but there are better options. And take a look into some of the new stuff that's coming along. You may well find that it can help you to debug your performance or to improve your security. And that is all I have. So if you're interested in learning more about these headers, I wrote a blog post with all the information that I gave you today. You can find that on our blog. This first edition with the ones we don't want will link to the second part, which is the good ones. And you can also find slides at farsi.us/headers, which is a longer version of this talk, which, if you can imagine, I deliver a little bit more slowly. Thanks very much. Does anyone have any questions?
Thank you very much, Andrew. I'm going to give everybody again the chance to unmute themselves and turn on their cameras in case you have any questions. Jose, what do you aimed, but thank you, open ending, he said. Not sure what that means. I have a question. So what if you can't control all of the headers that are set by the hosting provider?
Okay, so this is in cases like if you're using, say, S3 or Google Cloud Storage or something like that as a backend, you may not necessarily be able to control the headers that those providers set. So I would say two things. One is that in many cases you actually can, and it's just a somewhat hidden setting, but do look at the manuals and the online developer guides for those platforms, because they tend to have some kind of API for setting those response headers. If you really can't, then best thing to do, use a CDN, Fastly, or any CDN that does what we do would allow you to modify response headers as they go through. And that's a good place to remove all the cruft, like, Amazon request IDs and all of that kind of stuff.
Would be good if I unmuted myself. We have another question here, Andrew. I don't know if you can see it.
Oh, yep. Okay. Lots of gotchas. Should browsers set sane and defaults? So this is a continual argument that happens in the standards community. Is, to what extent do we create new features that change behavior versus creating the ability for developers to specify the behavior they want? So in some cases, what we do is we take the opportunity of having developers opt into one thing to change the default for something else. So, for example, so you might be able to hear kids shouting in the background. So my neighbor's playing the gun. So, for example, service workers. People want service workers, and as a standards community, we want everyone to have secure websites. So an obvious thing to do is to say, okay, you can have service workers, but only if you serve them over HTTPS. So sometimes you can connect a default that you want to try and push and try and roll out with something that a person has explicitly opted into. But to just change a default behavior of a browser is extremely hard. Google's been trying to change the referrer policy, like the default referrer policy, for a very long time, and I think they're now finally going to do it. But it's something that takes years.